All right, welcome to lesson 4.08. Here we're going to solve radical equations in context. In other words, we're going to use radical equations to model some real-life situations and answer questions about them. All right, so let's start off with this problem here. Go ahead and read through it, copy it down, and as you're answering, I want you to do two things. Pay very close attention to them. Annotate what both the input and output variable are and what they represent in this situation. So not just in general, but in this situation. And when you find your answer, I want you to justify it by sketching a quick graph and see if it makes sense in the context of your graph. All right, so two things here. The first is that t is the time in minutes since takeoff. So for example, if we take off at 11 p.m., 60 minutes later will be midnight, 12 a.m., and that will be when t is 60. And f of t, so the output, is the number of meters above the ground. So we want to know when the plane is going to reach 235,000 meters above the ground. So we're looking for how many minutes, looking to find a value for t, and we want f of t to equal 235,000. So coming up with a plan here, we want to set our function equal to 235,000 and solve for t. Alright, so at this point, what I want you to do is follow the inverse operations to solve for t. And what we do is we're going to actually divide by 10,000 on both sides. So go ahead and do that now. And then we're going to square both sides. So we're going to end up with 235,000 divided by 10,000. I want you to compute that on your own. Equals square root of t. And then we're going to square both sides. And then in your calculator, you can compute this and find that t is going to equal 552.25, which is of course going to be in minutes. And we want to justify this using a graph of our function. And so if we go ahead and sketch a graph of the function here, let's say that we go ahead and start our function off here at 0. 0, comma 0 is going to be the first point in our domain. And the function is going to increase like this. And to justify it, we can go ahead and plot a point, say, around 550. So maybe take 600. Okay, so 10,000 times the square root of 600. That's going to be 244,949 approximately. And so if we graph that point, 600, and this is t here, then the point at which we are in our graph is going to be 244,949. And this makes perfect sense because we are saying at 552 minutes we're going to be at 235,000 feet, or I'm sorry, meters above the ground. And I should label my y-axis as f of t as such. Alright, so when we're answering real-world questions, there's a couple of things that are going to be key to us being able to answer them efficiently and correctly. Let's go ahead and write those down. So first things first, you need to make sure that you precisely identify what the input and the output variables represent. And when I say represent, I mean specifically in the context of that question. That'll make it a lot easier when you know what your answer is and you can put the correct units on it. A quick sketch of the graph of any function will help you contextualize the scenario. So if you label your axes correctly and you sketch your graph either before or after, you will have a pretty good idea of whether or not your answer makes sense or not. And of course, I should probably put this first, to be honest. Make a plan before you solve. It is so important that you have a clear and concise plan before you go solving or doing any work, so that you know, you have faith in what you're doing is going to allow you to find the correct answer. Alright, so let's get started on this task here, and we'll complete it in class. Alice and Brianna each participate in a 5-kilometer race. Alice's distance covered in kilometers after t minutes can be modeled by the equation a of t, which is t over 4, and Brianna's progress can be modeled by this radical equation right here. Now, I want you to go ahead and answer these questions after you follow those key points that I just put on the last slide. And I want you to be mindful of this. When people are participating in a race like a 5K, everyone doesn't start right at the same time. And what I mean by that is there's so many people running that not everyone starts or crosses the starting line at the same time. So there's a little chip in your shoe that gets activated when you pass the starting line, and that triggers your starting point. And then when you pass the finish line, it clocks your total time. So the first question, who starts first, makes more sense when you think of it in this way. And so do so, and that will help you make sense of your answer in part A. Regardless of whether you're able to get A or not, you should be able to move on to B and C, complete all 3 parts to the best of your ability, write out your answer in complete sentences. And we'll take a look at it as a group tomorrow.